Yeah, MEV Nation. So we're back again with the PON MEV intro. This time we're ready to go. It's a V0 release for Gurley. It's already all the softwares are up on the public repo. Um, the whole MEV infra is on an MIT license. Anyone can use it. Anyone can fork it, build on top of it. Problem to the basic of this MEV infra for the proof of neutrality is layered. It's not really a monolithic infra. So let's take a step back why we're doing and what we're doing here. Currently, the MEV infrastructure is very brittle. It's an off-chain, off-protocol PBS system exists without having a PBS system actually in practice. So we want to bring some, at the first step, the damage has done to the Ethereum network. Let's all be very clear on that one. So the first stage is damage control of the users and the protocols, and every Ethereum user in the ecosystem is struggling with this overarching censorship and the bottlenecks of the existing MEV infrastructures. We want to give back that control to the users, and in a fair and open way. So we built an infrastructure that super lightweight, very modular, and in protocol PBS scheme. What that means, there's a lot to you know, unbundle stuff here, which we will go through in this chat. So let's take the overarching view. You have an in protocol PBS proposer builder separation as a contract suite that will handle on-chain registration, payments, and bring transparency, and also bring optimization for optimistic relay, and how can you coordinate with multiple off-chain parties. And this is a different smart contract architecture. It's also very modular. It has a registries, which handles the proposers, which handles all the validators registration, which handles the builders registration, which also handles all the data integrity checks. If there is something happen, deviate, like for example, if the builder cheat, if the proposer cheat, then the data validation need to be happen. So quote unquote, that is called the data integrity check. So to penalize that party, to bring back the game theory perspective, it's called ZK reporter, RPBS system. We'll go through that one. And then we have the off-chain part, which is in the current scheme, you have a relayer, and then you have a builder and the validator client, and validators will just go and do it. But here we bring in more programmable, more transparent architecture that a relayer is only doing a message brokering. That means it doesn't really see any of your block content, and it's also super lightweight. It's very optimistic relay kind of stuff, very fast. Anyone can host it, so that's a relay. We're also bringing a proper auction, which is very important. So currently in MEV, there is no auction, period. Whatever they call. There is no auction whatsoever. But we've been told there's an auction all the time. So the desiderata for an auction should have certain things like, you want to have an auctioneer in between. There should have an open. There should be incentive alignment, all kind of stuff. So if you want to have an auction, you should have an auction layer. That's very hard to build. So we build an order-flow auction layer in a bulletin board system. So think it like, you go into a DEX system, you can see the maker taker like that, but it's like a very auction. So second price ascending auction. So that will actually happens with full transparency. So the validator can get maximum value. The builders can get complete transparency on how the bidding is happening, and they can optimize it to get a better bid on the last millisecond basis. In order to make a full-fledged auction, you just need to have the infrastructure to be fully capable to handle it. In the current structure of MEV, it's not possible because if you take a peek into how the MEV infrastructure works, you have a validator client, you have a relayer, you have a builder. The validator client is the one that is validators run boost, and then you try to communicate with the relayer, and then the builders communicate with the relayer. However, the way it's structured is very, very vague, and it's not allowing any kind of auctions because it's not working in favor of validators. It's not even working in favor of builders. It's not even working in favor of users. It's working in favor of a very proprietary, pipeline that just relayer just to push this bundles and blocks, whatever they seems to be right. So it's very much opaque, but we need to have that. So we bring the client validator as well as the next phase. That's MEV plus. That's not part of this package. So we have certain difficulties to get that a full programmable auctions, kind of any kind of auctions to be in place, because not we cannot do it. We can do it. The software is there. You can see the code base is there, but the client is not allowing, to be very clear. Existing infrastructure sucks. There's no way you can sugarcoat this. And it's getting worse and worse on a daily basis. We will see the secondary order effect, like, more and more HFT trading companies are coming in, creeping in, literally, making all this DEX LPs ransom of their HFT, sex DeFi arbitrage. If you want to make sure that the credible neutrality of Ethereum is preserved, and if you want to onboard users from all around the world and not let their money to be a wealth accruing, honeypot for 2 or 3 or 4 or 5 traders or some corporate bodies sitting in somewhere, we need to have a very neutral infrastructure that gives transparency. That's what the blockchain is all about. That's where we all are here. So we want to make sure that the relayer will not see any kind of block contents from the builder. The builder has a complete agency. Now that will enable more, the supply chain can be organized to the builder, and the builder will only reveal the block contents once it receives the validator signature from it. And this also brings anyone could be a relayer in between, so they don't really have to. How this is happening is with a zero knowledge scheme, very lightweight, super lightweight. So that will do this data integrity checks post block if there is any deviation happen, and it penalizes it. So there's a very modular architecture. The current MEV infrastructure for the proof of neutrality accommodate every validator, every relayer, every builder out there in different way. And we're also going to touch that one. So regardless, block native, flashboard, and all this kind of construction, you can still use the registries and the smart contracts. It's fairly open, permissionless. Builders, validators, also known as proposers, just register. You're just registering one time. Now you have all this information available for everyone to coordinate. If you want to have builder privacy-aware block building, use our builder software, and that will allow you to propagate to all the users, the proposers, and then you can do it. It's a platform. It's a very beginning. Now the software is available. It's on the Goerli. We're going to take this to mainnet within a few days after the testing. But feel free to test. In this walkthrough, we're going to touch the mechanics and how can you set it up your own PON system as a builder, as a relayer. If you're just a validator, just go and register it. That's all I want to give to Vincent. We'll start with the basic architecture, and then we'll unpack a lot of exciting stuff.
Yeah, that's awesome. I think there's definitely a lot to unpack there. So we need to start first from maybe it's best if I like share my screen. I think what we want to do is really start with why is proof neutrality a platform? So we'll just refer to some of the stuff that we've been talking about. So we've been talking about PON in East Denver, ECC. So we can just refer to some of that material and literature really that from there. So Matt was alluding to so concepts that if you are following along in the MEV world, you're familiar with concepts such as builders, proposers, relayers. Reporters will be sort of a new concept in that sort of hemisphere, but a critical one nonetheless. but what actually we need to take a step back and sort of like just discuss a bit more about how this is really a platform. And the platform starts from a smart contract perspective. So that is referring to sort of an on-chain representation, on-chain credentials, a single set of credentials that can be referred and by anyone on and off chain. So builders have an on-chain in this platform, which, like Matt says, you can use alongside a regular Flashbot relay, Dreamboat, whatever it is, PON relay as well. This is your on-chain registration and representation. And it is where the builders will, so builders don't have to upfront have a reputation to get started in the building business. And they basically overcome the need for a reputation at the start by putting up skin in the game. So upfront collateral in the registry, and anybody can query that on chain. Anybody can sync that. That you don't need additional DBs outside of an Ethereum node, DB. So what that does is that allows it allows the number of builders in the space to expand massively, and we need more builders. We need more builders for the strength of the network. We also need more proposers to strengthen the network as well. And again, the proposers also have on-chain registration. There's no collateral associated with proposers. Proposers already put up 32 ETH to become a consensus layer validator. But again, we have an on-chain representation that everybody can sync against. And the main party of interest is the relayer here. So the relayer, the proof of neutrality relayer, is going to be the one that is deciding. So the proof of neutrality relayer is very lightweight, as Matt said. It is only doing header parsing, and depending on the strategy of the relay. So there is a default strategy. So this is the other side of things. There is a default strategy, and that is an ascending second price auction. So that will be the goal there to be, giving the proposer at the end of some time frame and deadline, the proposer the highest bid. We have some limitations in the supply chain, and where bids can be requested early, but we have some workarounds for those limitations with some new software that Matt was talking about that will come. So MEV Plus will alleviate that on that side. And then a lot of the arguments.
We only have
Sorry,
limitations. We only have limitations in the existing supply chain.
Right. Exactly. Yeah. That's right. But short term, I would say, very much short term. And one of the things that one of the sort of people say, some people might be against optimistic relays, and a lot of the arguments associated with that are associated with or not just optimistic relays, but certain modifications made to existing supply chain and infrastructure. A lot of the arguments is, okay, so what happens if you miss the slot? Will this change lead to a slot being missed, and what are the repercussions of that? Do we need to, is there any kind of demotion required, and all those kind of arguments? And we don't have a need to worry about any of those issues because we have the reporter in the game. The reporter is the actor that basically will detect any kind of issues with the builder, and any kind of griefing that maybe a proposer might do. And so post block, the earnings of a builder and proposer can be adjusted, and will keep the system it will help the system reach an equilibrium. So in This is so these are different ones, but in the Paris presentations, we spoke about how we were working with 20 squares, and they did a model showing that the system sort of works in equilibrium. But it is this dual framework. We have an on-chain registration, on-chain registry, and off-chain we have this zero knowledge scheme that brings the credible commitment. So the credible commitment is about it's about verifying that the builder really did. If the builder makes a claim, there is a credibly neutral way of verifying that a builder said they were going to pay a proposer, and if they deviate from that, there is proof that they made that promise, and then they deviated from that. And because of that, we can then apply penalties on the basis of that. So we have like portability properties with the scheme, and more details on that will come from Peter when he sort of talks about the RPBS scheme. But yeah, a lot of the work that has been done, has been inspired with the work by done by other people, but this is sort of this is our approach to it, and hopefully it will help sort of bring Ethereum back on course in the right direction, really. So what we want to do is show you full system end to end, getting it up and running, how you can get started. We have our PONPBS GitHub repository. You'll find there an implementation of the Proof of Neutrality relay built from the ground up. You'll find the builder as well. You have the list of smart contract deployments, reporter, as well as how to spin up your own local testnet, which we'll go into now. The other thing is we have a Proof of Neutrality SDK. Proof of Neutrality SDK. So that is this SDK, and that will help with various things, including registering your proposers in the proposer registry. All of these contracts are wired up to the SDK, and they make the job of doing the BLS signature verification. All of that is taken care of for you via the SDK. So we have we have all of these things sort of locked and loaded, and we additionally have we also have what we want to do and what we try and pioneer. So Blockswap tries to pioneer simple, straightforward user experiences, and getting and helping proposers register as easily as possible, reporters register as easy as possible, builders as well. We want that to be as straightforward really as possible. So because of that, we have a DApp that tries to bring and give users 60-second experiences. I think here we have, so we can show you, let's go to Gorelli. If you were on Gorelli, you wanted to connect your wallet. If you had, let's say you've got some proposers ready here. Some of them activated, some of them not. You can see your earnings as a proposer. You can go here and upload your key store. This will unlock the file and allow you to do registration. This is me registering a proposer with the PON registry, PON proposer registry. I do not want to switch networks. And it's as simple as that. I can just connect my proposer to the correct relay. So the standard software today is MEV Boost. Tomorrow it will be MEV Plus, but either way, you connect your relay, you specify relay URL. You don't need to do off-chain registration with the PON platform because your registration is on-chain. The off-chain registration to every relay you're interacting with is redundant, and that's just a tip of the iceberg into how why a PON relay is much more lightweight, much more easier to run, because you don't have excessive data storage, and lots of things to manage off-chain. A lot of the excessive things that the off-chain has to manage has been brought on-chain and reusable by anyone within the PON network. That's the goal, is for the benefit of everybody, is to have these smart contracts that people can sync against. And so you register once here, and you can use a flashbot relay, a PON relay. You can use many different ones with different strategies. And so it makes coordination much more straightforward, and helps make the market. It sort of allows the market to try and reorganize and make it more efficient, and help keep the network stronger, but also whilst benefiting proposers and builders and everyone in between, really. So I do encourage to use the PON dApp for your registration, but we also have an SDK like I was showing as well. So we've got a lot of pieces of software to show you. We can, if you just let me just try something here. I just want to do some. So one thing that's really interesting to talk about is, so I guess it would be unfair for me to mention MEV plus, but not give you sort of more information on that. Let me just bring you something here.
It will be good to touch like why MEV plus is needed, because you need to have in protocol. PBS and other actors can build on top of it, right? It's expandable. It's much more lightweight. It's kind of a standard template that anyone can just add extendable modules. And going forward, the protocols can actually add their own logic and things. So it will become more accessible for both sides of supply chain, right? Maybe just give some idea.
Yeah, sure, absolutely. I mean, at the end of the day, when it comes to MEV Boost is tailored towards a single application. So the application is simply allowing validators to outsource the block production and maybe get paid for that, right? So that's really tailored towards
just
to relayers, right? But that is one application,
Yeah.
In terms of, we have all kinds of new applications emerging, restaking, service providers wanting validators to run additional software, pools and stuff like that. So, that's tailored to, so Boost is only users have access to. And won't build this from the ground up. Sorry. Now the idea is for it to be very modular. So we to follow like sort of a plug and play modular architecture. So you have a core that would adhere to at least the builder API. So there's nothing wrong with the builder API, but then we want the modules to actually enable new kinds of applications. So when you configure your MEV Plus, you would have all of these modules that you can just add on. So if you want to have like a flashbot relay block, a block outsourcing, you can attach that module. If you want to have like a restaking, where you subscribe to running additional software. If you want to do on-chain validator registration, you can do that. So it's much more flexible, much more expressive, and very extensible. MEV Plus is really simple and dumb. It doesn't adhere to any single sort of like application. It's not tailored towards one kind of application, but it's tailored in such a way that it can be a validator proxy software over the builder API, but allow any applications to be built around that with the module. So the idea is, like you can build a marketplace here where anyone can write their own module, and users, when they configure their validator with MEV Plus, they'll be able to attach the modules that they are interested in, and the rest will take care of itself, right? So right. So basically, we have MEV Plus here. We are what we have here is really, really simple. We have, these services. We have service discovery, but all the services, as the slide alludes to, right? So the services just listen to events that get shared from the core. So the core can emit events that the modules like listen to and potentially react to, and maybe don't react to. But individual modules can broadcast events via the core, and other modules can listen and react to it. So you might have, like a logging module, or a module that collects information and posts it, somewhere else. Or you can imagine there are all kinds of possibilities here. You can have remote signers, modules that implement and write your smart contracts as well. So this is definitely, writing a service will be as simple as adhering to the interface, where you simply handle event. You have you are able to handle a start signal, and you have some kind of identification. There is service discovery, and users are able to actually when they spin up MEV Plus, they'll be able to inject flags that are specific to the core, but they'll also be able to inject flags that get passed on to the individual services. So, it's in theory, it's very straightforward, like very simple, very extensible, and will bring about lots of new sources of revenue and income for validators. So that's never really a bad thing for validators. Yeah, so that's, I think, like, fairly high level overview, but I think we can get sort of into sort of more details. We can go into Builder, what's the state of that? How do you spin it up? Looking at it on maybe our local testnet, etc. What do you guys think? And then we can go relayer, and we can show you the RPBS stuff. We can talk about the reporter, show you some examples how to run it. Does that make sense?
Yeah, it would be great to show that how to set it up.
Okay, sounds good. I would just share my screen. Okay. All right, so builders are essentially entities that more or less curate transactions, whether private or public, in the mempool to relay to proposers, either for personal gain or as part of a joint organization to provision or facilitate transactions without them being revealed in the mempool. So for PON, on our docs, builders in the entire network basically have one rule or one obligation in paying proposers, in this case, by including a payout transaction within the block they are building. This gives builders the liberty to insert any other payout pool address as the block's MEV rewards, but still maintains the market flow order for the entire network and the entire PBS system for proposers and builders as well. So in that case, you have a transaction that would be verifiable by these reporters that Vincent had touched on within the block produced by a builder. This provides extra security because the transaction has that verifiable information that it was from this address, from this account, and was signed for this amount. Now, considering that the entire PON architecture has an on-chain registry, having such a transaction that can be reviewed later on chain, weeks later on chain, can still be tied to a specific builder by the given ECDSA address within the transaction. This is a bit advantageous as compared to just having a proposal's address or an arbitrary address within the block for MEV rewards, if that's the case. So builders can benefit from extracting MEV from blocks, but still maintain a responsibility of paying proposals within the network, and can be slashable because as a builder within PON PBS, your starting points would be the DApp or using the SDK in any project that has integrated PON to register your wallet. So starting from the DApp, from the on-chain point of view, you could connect a wallet as any user can. And in connecting a wallet, you then have to pay a starting collateral to register your builder. After which registering, actually, you can view the amount of ETH deposited for your builder, in this case as collateral, and then this is more or less the only red tape you would have to cross in order to join the network. So this alleviates a lot of censorship and a lot of needs to register on chain, a lot of needs to identify yourself within the offline software as well. And this also ensures that you as a builder, you conform to more or less the right rules, doing the right thing, and everybody else conforms to the right rules, because you can't be penalized against what you have staked on the contract as well. So to start, once that is resolved as a builder, you can more or less start block building using the off-chain software. So as mentioned on-chain, as I had done, you'd connect your wallet, identify yourself, register, and deposit ETH as collateral. After which depositing, you can have access to this managed dashboard, to which you can manage your deposits, top up as required, if you have any balance that has been slashed from wrongdoing by yourself, to maintain your presence in the network. After which you can move on to the off-chain software. So the off-chain software is a variation of Geth. So Geth essentially is the Go Ethereum implementation of the execution layer client for Ethereum. And as this is more or less almost like an injected module within Geth, you maintain Geth's layer of security, Geth's integrity, and you can still run the software and still contribute to the entire network as your normal task would have done, without having to necessarily run PON. So if I go to the GitHub repository under PON PBS, the offline software can be downloaded and then installed either on your EC2 instance or any cloud services you're providing, or locally as well, and spun up to connect to any existing relay infrastructure for PON, or you can just maintain the Geth software without running the PON builder module within it, and still be able to validate the chain, carry the chain forward, and then import, deposit, transactions. Just do your day-to-day obligations as a node runner with this software as well. So going back to the documentation, how to run off chain, you basically need this builder variation of Geth for PON and a consensus layer client of your choosing. The introduction of withdrawals requires that blocks built for the chain include a list of withdrawals for that specific slot or block in this sense. And so gracefully, this information, this data is provided at the point of which the slot more or less is about starting, to which the consensus layer client can begin within its own builder API, if you're using Lighthouse, for instance, begin producing a block ready for proposal. Now, to make this accessible to an external client, in this case, Geth, which is like the PON builder Geth, which is an external builder, you need to introduce some flags in the current consensus Lighthouse softwares and Prism softwares as well. You need to introduce some flags that would allow this payload to be prepared ahead of time, knowing that you know the list of proposals for a given slot at the start of every epoch. Now, these are some of the flags that Lighthouse would allow you to set in order to provide this withdrawals and payload attributes data ahead of time for block building. And I believe with time, they would be more available based on the consensus spec as an endpoint to retrieve withdrawals information. After which, you definitely do need Go to install the builder software and setting Seagull flags as within the Geth implementation for the builder. There is BLS signing, and depending on your system architecture, you need to set some flags to support this as well. So after which, the last piece of software you need is the Blockswap's RPBS signature scheme. Peter would go more into depth, and Vincent and Matt could touch on this, on the RPBS architecture and logic. But this is a signature scheme that would be used by the builder to verify the presence and the validity of the payout pool transaction within blocks built by the builder for the network. So this verifiable signature, aside the transaction actually going to be on chain, or if the block failed, can be verified against the builder's address and against on-chain data for the presence of that transaction within the block, and for the validity of like the amount to be paid to the proposer if being promised. So this would allow the relays to be a lot more optimistic, because you have this signature without having to run and simulate the entire block for a valid amount or amount states change within that particular block's transactions. But you can take this signature as a verifiable proof that you can report and more or less hold the builder accountable to when the block is proposed to pay out the payout pool. And as mentioned, you have collateral staked against. So all of these checks outside making the network more free and lighter and easier and open, there are still a lot of security layers and checks which don't have any like additional major additional time costs or working costs to the entire flow, but still gives that guarantee and that confidence that every party is acting correctly. So once the software has been downloaded, let's say I download by zip. Once it has been downloaded, you could then unzip it and go into the repository of the software. And just as any Geth execution layer client, you could, so you have your builder software, which you can then unzip. And this contains the entire folder and all the functions and modules within Geth itself. So just as any Geth execution layer client, you can go ahead and run make Geth, and it will install the entire Geth package as you'd expect it to do. Also installing the builder software as well. However, if you are more technical and you have additional build flags to include, let's say you want to build a Geth specifically and Geth's account manager specifically, you could go ahead and run run the build CI-go function and pass the install arguments to install Geth for that specific configuration you want. So you can add additional flags to your choosing. Once that has been done through this method, however, you need to make sure you then copy the build binary into your local bin so that it's accessible globally. So you could run, let's say, get from your terminal or from your root directory or from any other folder to start your execution layer clients wherever you'd wish it to start. So in that light, you have let's say I have a new screen as, let's say, let's call it builder cd POM. So in that light, you'd have, as mentioned, everything you've downloaded from our software here for you to build. So if I do build export, so again, you must have Go, and then if you have that, you then install your Geth variation of the builder software and make sure to copy it into your repository. After which you can start Geth manually. Terminal. Yes. So after which you can clear that. So after which you can start Geth as normal with the required flags and any other attributes you'd wish, but you need to include the required flags for the builder software to run.
So which are the most important ones here? Like, is everything mandatory?
So within the repository, gratefully, the README also mimic copying what is on the docs. The README within the repository is thorough in how to install the builder software and run it as you do with Geth. But these are the additional flags you need to include for the builder to, in a sense, activate the builder software specifically for PON block builder in this sense. So you have the ability to include beacon endpoints you'd want to connect to. You're allowed an array of beacon endpoints to ensure maximum uptime and maximum performance, because you may have some nodes that are in sync or out of sync. And the additional APIs you need to include. So Geth, the execution layer client, will allow you to connect as an RPC for sending transactions, getting block number, getting gas estimates. But you need to include this MEV API flag to allow, let's say, bundle, passing of bundles, passing of private transactions to your builder software. But the README includes all the specific flags you need to provide the builder software, in this sense, Geth, to run the builder appropriately, many of which are not required. So you have a few like metrics which maybe you don't need to evaluate the performance of your builder. So a few of these are not required. And for instance, you don't want to run a bundle service. You just simply want to build out of the mempool. A few of these flags will not be required. But the required flags, however, would be the need for a relay endpoint, a need for a beacon endpoint, and of course, a listening address to which you'll be placing block bids out of. So if the builder software had been started appropriately, you would have a clear indication of your Geth system starting with the builder service registered on the specific endpoint you had provisioned. And in this sense, I had started the software with the flag of running a bundle service. And so you'd have logs which efficiently tell you what exactly is going on and the kind of services you're running and the kind of actions or errors that are thrown alongside. But let's delve into what exactly this software is doing. There are sample command line arguments provided for you to start your builder software out of the box, but definitely you need to replace your private key and your BLS secret key for the signing of the transaction, of course, with a builder wallet, and of course for the signing of the entire block bid to be verifiable on by the other entities as well. So within the builder software itself, The builder software is just a single folder within the entire Geth library, which has an entry point builder.go. So builder.go is the software that is the entry point for the builder that has all the required builder configurations that you pass as command line arguments on the specified relays, the specified beacon endpoints, and of course the need for RPBS as well as the RPBS service, of which creates a builder instance for you for the software to begin block building.
Could you explain what is the RPBS? Like, why
Okay.
do you need it? Yeah.
Okay. So RPBS is a, let me see if I will be able to
Now,
find.
what is actually brings for the builder? Why the builder need RPBS?
Oh, great. So as I,
'Cause
um,
it's not standard with MEV infrastructure now.
yeah, that is correct. So as I mentioned before, for the builder, you simply just have to include a single transaction within the block. Let me go back to on-chain. So as the builder, you need to include a Yes, you need to include a single transaction into the block as payment to proposers. Now, RPBS would allow you to include this transaction with the guarantee that you have more or less attested to the existence of the transaction within the block. And it's almost like you're pledging that there is a transaction that would be paid to the payout pool, and you can be held accountable to that. As a builder, that gives you the liberty to then set the fee recipients of the block to a recipient address of your choosing. So with a bid process in mind, you may have a, a block value of a different amount, but with an open auction and a bid process in place, having committed to, let's say, bidding 2 ETH, it may not be the value of the block, but you have committed and have put yourself to that amount of 2 ETH to the proposer. So setting just a fee recipient as the proposer's address might not have the full value of that finalized auction being paid to the proposer. So having this transaction as the paying transaction and being it verifiable and accountable would give you the liberty of setting any other fee recipient as the recipients for the block, and either you retain those MEV that value from the block, or depending on any other protocols you're involved in, you can still contribute to those protocols or those requirements by having that protocol's fee recipient for the block's fee recipient address. But with RPBS, you're allowed to have this single transaction and allow this freedom because RPBS would give you that verifiable signature that you can attest yourself and other parties can attest on chain of paying the proposer in the case of any other grievance. So that's one of the benefits of RPBS for the builder in this case.
Right. So,
But oh gosh, sorry. No, I was just gonna say, like, does it help in any way with like the builder retaining their block contents? Like,
Yes, it does. So in PON, we have the salient point that you're not revealing any of the transactions to the relay. So the block that you build, in a sense, is a blinded block or a blinded execution layer block is relayed to the proposer. So there is this attestation through RPBS that there is a transaction in this sealed and hashed block that would contain a payment to the proposer, upon which the proposer selects this block bid as a finalized block for the slot, would have a transaction on chain that matches this attestation. So with this in place, you don't need to review the entire block content for a relay or proposer to evaluate your entire block. I mean, they may a strong emphasis on may be good actors to just see that single transaction and, of course, approve and understand that you are intending to pay the proposer for the slots they're offering up. But other proposers may see the entirety of other transactions within the block and perform some actions, or disregard your block and perform other actions based off of the kind of transactions you're intending to propose to them. So RPBS will allow you to pass this blinded block to relayers and proposers without revealing any of the transactions, but still have that guarantee and that attestation that you would include the transaction on chain upon the block that meets the block hash upon it being sealed onto the chain.
Let me try to rephrase this the way that I understood this one.
Okay.
In a normal MEV construction, so PBS, off-protocol PBS construction today, you have a builder, you have a relayer, and you have a validator, right?
Yeah.
In the current construction. Of course, the builder can directly go to the validator, but the problem is these two are two different parties. The builder is giving a payload currently to the relayer, full block. That means the header and the block content and everything. And there is a predefined structure that currently, like the most desired structure is the last transaction of the block would be the payment to the validator. So, that's easy for verification, right? And it's also the least gas price from a priority gas option, right? Top of the block to the end block. So you will pay to the validator, and the relayer is easy for checking what's the payment amount. That's how it is getting verified today.
Yeah.
There's no way in a set in stone requirement from an Ethereum perspective. This is more of like an optimized rule that has been followed across the board for the MEV relayer based construction, like just to make it sure that the bid payments has been easy to verify, and then everyone can just follow that rule. So let's assume that the builder is giving all the block content to the relayer, and the relayer themselves are a builder too. There are multiple problems, and this could be leaked into the validator, and the validator can steal the value, and then they will not sign it, and they can propose it to the other way. You can see that the relayer in between can hold this. So you need someone to verify this. You need someone to simulate it. It not only makes censoring, it also brings a lot of simulation requirement, a lot of heavy lifting to the relayer to do all this kind of transactions, right? So every bit. So the builder in PON, what you're saying, the builder is not revealing the block content to the third party, right? The intermediary between the validator. Okay, that's a great thing, but questions need to be answered. How the block validity, the block validity can be enforced, right? Correct validation, and what is a cheating can happen if the block can be tampered, the content can be tampered later on. What if the payments is not enforced to the validator? The validator only has one chance, but also the validator can also be malicious. So builder need to protect their value, validator need to protect their value too. So if you neutralize the middle party that is actually doing this kind of checking, you need to bring guarantees. So RPBS is a standard system, but in the PON, it's a customized a signature, a non-interactive zero-knowledge scheme that use RPBS. Just to be very clear, it's not a vanilla RPBS, but it's use RPBS. So the builder can create a non-interactive zero-knowledge scheme, but then it is not transferable. It's normally RPBS are interactive zero-knowledge schemes, so we need to make it non-interactive zero-knowledge scheme. So we made that one to a non-interactive zero-knowledge scheme. Now you, as a relayer, will never get the block complete. You only get the header. So think it like it's a header relay. Boom, it's pretty fast. Rather you giving the full content, you give this non-interactive zero-knowledge scheme, which will give you the proof for the bid payment of the last transaction in the block, but also comes with a guarantee of the RPBS guarantee, the message cannot be tampered. So you can send that one. Once that is signed, no one can change the structure of the message. So this is a cryptographic property, so no one can do anything. So it creates this kind of self-witnessing attestation of its own block and say that I'm giving so a non-interactive zero-knowledge proof. I indeed comply with all the rules of the block building, all the rules of the builder payment to the validator. Here you go. Now I come to the auction, and the relayer is only checking what is a bid. The bids are winning. It just gives the header to the validator, and the validator will sign. They have the guarantee because the NISC can be verified anytime. If there is any deviation happens, you always know from the post block, you have the data availability on chain, right? On any block has happened, you get the data from the blockchain, and the reporter will cross verify if the deviation indeed happened, who's actually cheated in the system. Does that sum it up, or is it completely different?
No, that sounds about very right. Yeah.
Vincent, you're asking something.
Yeah, I mean, at the end of the day, the builders are simulating blocks on, they have Geth, right? So they have a block or not. Actually, simulating the block is not the problem. Like knowing whether the block is correct is really not a problem. And the reason that's not a problem is because the consensus layer, the nodes actually will validate your block for you when you try and submit. So if you try and submit a block and it's not got the right structure, it's not got the right signatures, right? Actually, the key concern is, are you going to pay the other party? You have one party with block space, and they've been selected by Randall for 12 seconds. They want to decide whether they can accept a bid or not on the basis of, are you going to pay? It's as simple as, do you have enough money in your account and stuff like that. So if it's only about payment, then why can't the builder just self-attest? Why can't the builder just self-attest and say, look, I have the money to pay. Here is the last transaction in the block, and I will do an RPBS self-attestation. Now, when it comes later, if the person was not paid, to go to a block that if a builder has bid for a block, the builder has bid, for a slot, the auction is happening on the slot, they will produce a bid, let's say 4 ETH. It will have an execution layer block hash. When the block gets proposed, you can go straight to the bottom of the block and look at the payment. The payment is either, what was attested or it wasn't attested, right? You have that attestation without revealing the whole entire block contents. It's really, really powerful here. If the only concern is a fear of loss of payment, there is no fear of loss of payment in Proof of Neutrality. No, we don't need to do anything inside, because we're saying, yes, things can go wrong, but there's actions to rectify, because you can just say, well, we can see that this builder self-attested. They said they were going to do this transaction. Here's the raw transaction bytes. Here's the self-attestation on there, the RPBS. And we can verify that they did sign this, and that it is, they definitely did make a promise to pay, but they did not actually do that in the end. So then we can actually, and that is on-chain and recorded forever. So as a builder, it's not in your best interest if you're trying to build your reputation on-chain with your on-chain, registry. It's not a good idea to play fast and loose, shall we say? Because you leave a footprint behind that is on-chain and visible for everybody to see. That's why it's important to have a platform which has an element of off-chain registration, because if everything is off-chain, people can hide in all kind of weird corners. Here we don't have any of that. But I mean, what would be good? So I think I know now, Ronnie, where to go in terms of getting this up and running. And we've seen it we've seen it start up, but can you sort of delve into the features really of this? If you want to show any code, if you want to show how to submit bids, maybe even if I'm a searcher, how do I send my bundles right to a builder? That would be awesome.
Okay. So the features. So in P1 implements a second price auction. So with everything configured as we've covered with your beacon nodes and RPBS configured and your relays configured, the main heavy lifting is done.
Does my beacon node need to be anything special? Like how do you actually like build a block with withdrawals? Do you rely on any special features of a beacon node to do that?
Yes.
Like
So currently, there is a move for the consensus spec to expose an endpoint where you can get payload attributes ahead of time. It will take some time for every consensus client to implement this, but many of the clients therein thus far have certain flags you can enable to allow this attributes to be proposed ahead of time as the spec would be conforming to. So for Lighthouse, which we have been using for our current nodes as well, there are the flags to prepare the payload and prepare the payload like a slot ahead, 12 seconds ahead, knowing certain attributes about the payload, like who's the selected proposer for the slot, the parent hash, the previous block hash, the block number, and the expected withdrawals for the coming slot. So this will enable, as a builder, for you to subscribe to like the payload attributes SSE event and get these signals of expected withdrawals for the coming slots for which you're block building for. Now, the majority of the heavy lifting is done within the builder's processor. So a rough overview of what the processor does. The processor basically has a callback function that is called within Get's block building engine that would then check after block building, check for conformity of an existing payout pool transaction, an existing bid amounts that was included in the block, and then validate, as Vincent was mentioning. Builders have these execution layer client softwares which work with the execution layer chain, so they can quite easily and quite quickly validate the validity of blocks even after the block has been built through the builder API engine with the consensus layer. And then you have this feature, this property we've introduced as slot bounty. So touching on what a normal bidding and block building process is, you have a block that would be produced with a ready payout pool address and transaction included, a block value which in a sense has the block's value of gas for the block you've built, and kind of like your MEV. I mean, there are other benefits to transactions you probably have included in the block, but this is the intended value of the block you would retain, after which the block gets placed on the execution layer chain to the fee recipient's address. And roughly the bundles that were included within this block. These bundles are of importance to individual builders, individual searchers, for inclusion within blocks that they've specified, or for inclusion within timestamps or time ranges that they've specified to builders in their interaction. I will cover that quite quickly. Now, as a builder, the quickest and default strategy will be building a block for maximum value to you. So if there is a block of value that is greater than existing or greater than previous, this is set as your more or less ready block compared to the fees that you already have for a previous block that you've built. And this is sent for block submission to the submission channel, upon which any successful submissions are relayed to the builder as a JSON response of what may or may not have happened. Now, as a builder, the entry points to this heavy lifting processor, which again interacts with the the Geth block building engine would be the point of bidding and the point of bounty. So I'll come to bounty shortly. So in block building, as mentioned, you can bid for the current slot. So for the intended auction architecture, which the PBS system should have, there should be in an auction, of course, there should be like some stipulated times to which you can, raise a auction value, offer to bid this amount, and at a point where you have that going once, going twice, gone stage in the auction. So these stipulated times are respected and deduced by the builder software automatically based on the current slot you're in or the proposed slot you're building for. Now, using the current slot you're in, there are certain time cutoffs of ideally within our auction architecture of 2 seconds to which block building and bidding can proceed, and then an additional 1 second for which a bounty block bid can be sent to relayers and proposers to agree on. I will come to bounty quite quickly after this. So you have the bid amount as passed by JSON IPC call to the builder and the slots you're bidding for, and more or less the times you're proposing to build the block for, and at certain time cutoffs the software must respect. In the builder software, we have, as part of the auction process to ensure fairness and reduce the amount of load and unnecessary bidding within the whole infrastructure, there are certain rate limits respected by the entire network of building and bidding 2 bids for a given slot. So we have this auction process where I may start with an ETH block bid, and I may be beaten by a higher value to which I can then have the opportunity to bid much higher or propose a bounty bid for the auction process. So this ensures this encoding this, more or less coding this within the software, ensures conformity for everybody running the PON builder within the network, and ensures fairness within the auction process as well. So coming back to quickly on the code snippets, you are able to access these payload attributes signaled by the SSE events from the consensus node you're connected to get details of withdrawals and withdrawal amounts ahead for your block building as intended, and get the known proposer for that given slot. These automatically, of course, fill all the required block attributes for the Geth engine. However, as a builder, you may provide these externally through the API for building yourself. So I will go down to the documentation on the right, where we have clearly laid out how you could interact with the software. So in interacting with the block bid submission route as a builder, you have the liberty to actually specify which slot you want to build for, in addition to include transactions at that point in time where you want to build a block for the given bid as well. As mentioned before, having talked about RPBS and the liberty to which you can set a few recipients for a given block, you can still conform to every other protocol's need for a few recipients within the block by providing the suggested few recipient route parameter within your code, to which the block's MEV or value of gas fee value would be rewarded to. This can be configured within bit scripts to automatically do or automatically include in your post call to the builder block bid endpoint, upon which is also available as a bounty bid parameter as well within as well.
So you can configure block, right? So you can configure the Coinbase, and then the payable address is where the payment is made for the winning bid, right?
Yes, that's correct. So you can configure your Coinbase separately, and also configure your payout pool address in your builder configuration as well. So going further, you have, upon which all the required attributes have been loaded for block building, you have these two unique more or less processes or code pipelines that handle the processing of your bids to the builder, to the engine, in a very managed manner, that you're not wasting resources, overloading your engine, and making sure you're building blocks specified to the given attributes, since many of these bidding processes are asynchronous, and you can stop a build at any point in time and decide to build a different block. So you have that flexibility. You're not constricted to completely finish your build pipeline. If you want to, let's say, change a certain attribute, let's say change the field recipient at a point in time when you're bidding with the builder software. So this starts two major pipelines that would be one running a normal slot submission, which is the normal bid auction process, and then preparing the block with the consensus engine. So your slot submitter, if I put the bounty on the side, which I'm easing too slowly, your slot submitter, the bounty has more or less the same attributes loading, but in terms of a bounty bid, there are other rules um, and requirements that govern how you bounty bid, which I'll touch on. But in a bounty submitters, in a bounty bid process, you have a similar slot submitter. However, your governing timelines are slightly different, in having a different bounty cutoff as compared to the normal bidding time cutoff as well. So you prepare your block till the bounty cutoff. However, you only bid until your bid cutoff itself. So you have a bid complete channel to which you receive like your normal bid, your normal auction responses to, and a bounty complete channel to which you receive certain bounty bid attributes and responses from. So these two building features will allow you to access the same building engine to build with the same reusable attributes and not heavily waste computational resources as a builder software, and still process in due time every bidding response. So currently for block building, there's an estimated build time with the builder software of about 150 to 250 milliseconds, averaging about 200 milliseconds to fully build, sign, generate RPBS signatures, and submit blocks to relays in due time using the software. So having this single pipeline that asynchronously can process all of these different auction methods, whether it's normal bidding or bounty bidding, would allow like certain attributes to be reused and the engine to be used more efficiently to block build as a builder. So that's a bit more technical into how the architecture and the heavy lifting is done within the builder software. So if you remember, this prepare block accesses the processing go routine, which would then access the builder worker engine to build the blocks for you. Now, to touch on bounty bidding, which I have mentioned roughly a few times. So bounty bidding in our ideal proposed auctioning system for PBS is the case where you have more or less built a block within the stipulated time, let's say the 2 seconds, and you have a need to, whether it's based on like the entity you're a part of or a certain transaction that has been executed late or included in the mempool late, or an extreme dire need to include an additional transaction at the latter end of the auction, there is a bounty bid slot period of 1 second to which you can propose a last block. Is like your very last chance at proposing a last block to be taken for during the auction process as a block of bounty rewards to which the bid value for that block is currently by proposal twice the current highest bid within the auction, or the current highest winning bid within the auction. This is there for extreme edge cases where you, let's say, have different especially where we have different configurations to build our softwares and different business logics behind builders who are parts of different entities, where you need a block of certain value or certain dire need within the execution layer. You still have this flexibility to go through the auction process and above the auction process to include this block within that proposed slot. So the bounty.go the Go file would facilitate the processing of, again, these attributes. There's nothing different to how you'd more or less bid, but just that your bid value is the considerable change in the way you'd be executing this bounty bid, and load those attributes, especially the fact that the code here is optimized for speed, because the bounty window is quite narrow. It's a second, and it's more or less the first to come with a winning bounty bid claims a slot. This is much more optimized for speed because you have certain attributes that you've already configured, and more or less you already know from building in the normal auction process, and you can skip a lot of preparation and payload attribute loading in order to build the block in much smaller time than the 250 average you'd build.
Right. Can I interrupt here for a second?
Yeah.
So the bounty bid is a situation where the builder has an inherent incentive or an interest to seize the ongoing auction with a large amount of ETH as a payment for validator, because they have something which is precious, right? The private value for that auction for that builder is extremely big. So quote unquote, let me break this down in a very simple terms of MEV. You see this kind of a top of the block TOB auctions. SMG has special mechanism group has done some simulation. Like you will see that whenever there's a C5 DeFi arbitrage, or when a builder receive a bundle with a large value, they likely to see the escalation of the bid at the last milliseconds of the block, right? Quote unquote, a block is at 12 seconds. And if you look at to the last seconds, the time period of the block, you will see a large bids are coming in because they just want to make it sure. And inherently, if you look at a general behavior of these builders who want to get this kind of a large bid, they already know that what they want to get it. They actually want to get that top of the block, right? So it's, if you don't know, generally, like general knowledge of Ethereum is a sequential state machine. So that's why it is the top of the block is very important. So you want to get the bundle to be in. So the bounded bid most likely will originate from the builders who will be serving this kind of a high payoff from the searchers, right? The bundles. Generally, not necessarily every time this will be satisfied, but in a general condition that we can anticipate the bounty bid is going to happen on the last milliseconds of the bid of the block, and also going to come from a searcher. So they have a large value inside. They want to just pay the money and they want to get through it. One of the reasons the bounty bid only start from the last, post the bid, because we don't really want to start at the beginning. There's no reason. Because the ideal agent for this kind of a bid would be the searcher bundle inclusion of a builder, right?
Yeah.
Cool. But the bounty bid is not included in this kind. So this is something that's very in line with what the MEV, the order flow auction guys are asking. Can we get some sort of a fast lane or priority lane? Just get this thing kind of a top of the block, and then top of the block guys will just pay extremely high price. Can we identify in some way? So PON basically serve that purpose without splitting the top of the block and rest of the block, but generally just you bid for the entire block, but you still have some sort of behavior pattern that everyone can look out for, and even the validator can optimize their request to the relayer and say that, oh, is there any kind of top of the block order is coming in? Most likely it's going to come in at the last milliseconds of the block, so I'm only going to ask for that one. They can do it, but there are certain you know um, shortcomings on the existing coordination system the MEVs will not allow you. So this boundary bid will not be fully utilizable until MEV plus comes in. Is that correct?
Yeah, that's correct. Yeah.
Yeah.
Yeah. So these two endpoints are specifically for builders. That's pretty much, as a builder, the main endpoints you'll be interacting with to create your blocks, send some of your blocks to the relay and get appropriate responses back. However, relays, of course, would return the blinded blocks to you, to which the software would automatically process, validate, confirm the attach signatures, and reveal the payload finally to the proposer. So at every point in time, there are not the action by a user is minimized for a more streamlined experience in using the software without having to juggle too many endpoints or too many scripts to relay information to and from the builder architecture. Again, the software is pretty lightweight. There is little to no storage unless, of course, you want to run metrics and run your own analysis of how your software is performing. To which, of course, there is a need for storage for bit amounts, bit values, bits that have been sent. So let's say you want to export this data later for post processing or for post reporting, you may
Do you have a dashboard?
Yes.
Sorry.
As a builder, you do have a dashboard actually. So the builder dashboard is as accessible as the home route for the builder, and you have that.
Can we see something? How does
Yeah.
it look?
So the builder dashboard is a dashboard that will give you more or less almost a full overview of the kind of relays you're connected to, the status of the network, and the kind of blocks you're building. So currently we have about 4 builders, 2 of which are running on Gorilla and 2 of which are running on a privatized blockchain DevNet we have put together. So on this dashboard, you can evaluate your software's performance and your bidding strategies as well, aside the responses you'd get. So you can see bids that you have sent through or slots you may or may not have missed because your bidding strategy did not execute certain bids at certain values. And of course, blocks you have won. The context of winning a block bid here is you sent out a blinded execution payload of which you are tested to payment for, and this was taken as the highest value for the given block, for the given slot by proposer, signed over and then returned to you, upon which now you have that signature and you as the builder hold the entire payload. You can construct the full beacon block to be proposed to the chain. So the relay and proposer cannot exactly tamper with the transactions within the payload itself, and you have that responsibility to publish to the chain because you are the very first point or the first entry to have the full scope of the entire beacon block that would actually get onto the chain. So having won this bid, by that sense, having that signature to which you can attach to your full execution payload, you would see every single bid you have won here, upon which you have metrics on the kind of value you're spending for a given bid for a given month. All of these are configurable and adjustable within the software for the different kind of performance charts you want to display, and more or less the average and the average MEV you're extracting from any of these these bids. So this is on our DevNet with little to few transactions, but on Goerli you'd see much larger availability for transactions where you have larger MEV from more transactions being included, with blocks being built with 66 transactions, 54, 30, just to fill up the block space for the maximum value you can get as a builder for that given slot. Upon which a block, if being won, you have block hashes. As I said, if you set this as a metric, you can export all of this data because this is stored within whatever local instance you're running or cloud instance you're running, to evaluate like certain block hashes that you may have expected to go on chain having won a bid. And then if you are running a reporter software, you can grieve the network depending on which bad actor did not actually propose or review certain block hashes that were won, or if your software was faulty in publishing the bid itself. So this is the dashboard that would be available to builders internally. You can make this externally depending on what protocol, depending on what party you're involved in, to review like the bids you're making, the MEV you're making out of it, and the average you're spending as ETH or in the entire bid, in the entire auction process. Now this is for a builder. Now quickly jumping on to the benefits and the interactions for searchers. The searchers ideally in any protocol would be interacting with builders by means of an RPC. These RPCs can be protected, whether it's through like get authentication module or an additional layer through your cloud infrastructure. But the RPC implemented through PON conform with existing RPC methods that almost every searcher or bundler uses currently to pass transactions or bundles to builders. So for a bundle being documented, you can pass a list of transactions which are the encoded bytes, which are quote unquote raw transactions, depending on what coding language you're using or what package you're using, to the builder, and the block number you intend for this bundle to be executed for, of course, maintaining this order, or the time range to which you want the bundle to be valid for, assuming a block number is not specified or is missed. There is a need, of course, for a list of reverting transactions. Your bundle may not have reverting transactions. In the instance where you're a protocol, you're an entity, or you're a person that's running a bundle service, and there was a transaction that a user to which, let's say, you're collecting transactions for, executed something else, or is attempting a transaction with a contract that is not sure might work, a list of reverting transactions may be provided such that your entire bundle's integrity would not be compromised if, let's say, that user's test transaction or that user's execution does not go through or is not validated on the execution layer, or taken when the block is validated by the builder. This can be tested. So this currently running with we have 4 builders, as mentioned, Goerli, DevNet. However, this can be tested. So as mentioned, it's a JSON RPC. I've currently connected to our DevNet RPC on the proposed port. The builder currently has a few RPCs on Goerli, to which you can check as a bundler the status of the given builder. Some, as mentioned before, some builders may configure their software to not run a certain bundle service. But you can check this, and then you can, of course, send bundles to the builder for the given, let's say, timestamp or for the given block number. So I would attempt sending our current DevNet builder as a searcher a certain bundle with these transactions for, let's say, the given block number. Let's put it at like 650. We won't have a timestamp because I'm targeting a given block number at this point. So provided bundles already expired because the current block number that current timestamp is that. So let me just increase the timestamp. Let's put that at 7. That is 1. Yeah. Sorry. Okay, so you can't have a, let me put that. So these are to protect builders from being overloaded with spam transactions. So if you have a bundle that one has little to no gas, or you have a bundle that's like long living with a long time span, there would be, as protection to builders, there are many of these checks in place, which I could show you in a code snippet, to protect builders from having to store long-running bundles or having to get a spam of bundles from searchers or bad acting entities, since the RPC would be publicly available to connect to from builders who are being transacted for. So a sample bundle having been sent would be for these given transactions and this given block number. I want a bundle that's executed with only certain reverting transaction hashes. You would then, as a builder, or I misspoke, as a searcher, get a bundle ID, which is which you can then retrieve from the builder software and verify that either your bundle was included or not, and check against the given block number provided back from the builder. Go back here. So that's to send the bundle. You have other functionalities to update a bundle having obtained this given bundle ID. So you can then adjust the bundle to change the transactions within it, assuming it hasn't been ready for block addition, or assuming your time range specified has not been reached. You can then adjust your bundle accordingly, after which you can't tamper with the bundle because it would be used for block building in this case. You can, of course, retrieve the bundle for bundle information, but we deliberately omit, since this is an RPC method, as security means there is a deliberate omission of the list of transactions within the bundle. This is for security for builders and searchers as well, from somebody accessing or from a builder trying to access this endpoint themselves to view the list of transactions within the given bundle, but you'll still get the bundle ID to which you can match against your own records, and then the timestamp and everything, and the signature, of course, that was signed over the bundle to, as I mentioned, verify that the builder did accept the bundle and can be held accountable on that side of the market. As a protocol as well, you can implement private transactions without having your transactions sent directly to the mempool. Similar to a bundle method, you don't have a list of transactions. Sorry, you don't have a bundle which has a conformity to how the transactions would be layered within the block, but you can pass a list of transactions. You can batch transactions privately. You can send transactions as individual transactions to builders to execute when block building. However, you won't be able to specify certain block timestamps and like the full functionality of using a bundle service as a searcher in this case. But you would have the case where if a transaction is verifiable, which the builder API, which the builder software would validate here. 1 second. You would get appropriate responses of the validity of your transaction, and if your transaction would be included in the block having submitted through this RPC method to the builder. So for bundles, if I come here, handlers, you have private transactions, which will of course decode the transaction. In decoding the transaction and attempting to add the transaction, you have the errors that of course would be these stem from get engine would then translate to the searcher or the private entity that's trying to add the transactional bundle as to the reasons why the transaction is either not valid, invalid nonce, or improper structure, or the reason why the transaction just cannot be added to the builder software at that point in time. So entities can act based off of these responses, and you would of course have a verifiable hash once the transaction has been added to the builder software for the block being built. In terms of bundles, the default the default processing method gone with is for bundles to prioritize, of course, block number first. So the bundles with intended block number 2, of course, will be processed before bundles which have an intended block number of 10 and 5, because you specified either like the time range or the block number to build a bundle transaction for. But also, builders prioritize bundles which have larger MEV. So within the notes for bundles that would be sent out, the strategy or behavior you would expect a builder to exhibit would be prioritize bundles with a higher max payout. So this is a disclaimer in the case where you have a bundle which has minimal MEV to the builder, there might be a chance where your bundle may or may not fail depending on the availability of space within the block. However, the builder software does this gas check within a specified block number for room for your bundle. So if you're sending a bundle and there is no gas space for your bundle, you will get an appropriate response to specify a different slot or block number. However, if you do specify a time range, bear in mind that a time range is a range of slots to which your bundle would be valid for. So your bundle may be inserted at a different slot than what you may be expecting. And this behavior will be governed solely by the builder's need to prioritize the max payout for themselves, depending on how they've configured the software. So that should be noted for bundles and for builders and searchers aiming to use the RPC methods available within the builder software. Aside that, as a builder, you have access to every other RPC method that you can connect to. So for instance, if I want to get the current block number, as a builder, I'll still be able to get, for instance, the current block number. So the builder RPC conforms to every available current get RPC method for the execution layer, and you can connect it to, let's say, any dApp or any wallet to still perform your day-to-day, let's say, ETH balance checks and gas estimates, send normal transactions to the mempool. But in terms of as a builder and searcher, you can access special methods through the MEV namespace for sending transactions to builders. So that's a general overview of what a builder is like and the current workflow of the builder software and how the market for builders and searchers would be like in accessing these RPC methods to the MEV namespace.
That's awesome. Maybe we can have some. Maybe PC can explain a little bit about an overview of RPBS, and then we can move on to the relay.
Yeah, definitely. So basically, we have. Firstly, maybe I could start with kind of little disclaimer, which could bring some confusion. So we basically have like two very similar things that sounds like very similar, and those things are like PBS, which is proposer builder separation, right? And the RPBS with like extra R prefixed. But these abbreviations are like completely different. So RPBS is a completely different animal, and this is actually the type of digital signature. So basically, RPBS stands for restrictive partial blind signature. So there is like a few characteristics of this specific digital scheme. So we could split this complexity and just move like kind of step by step. So firstly, we have like the blind signature, right? So the blind signature is a concept when, for example, you're as the recipient and you would like your data to be signed by some other entity, but you do not want to show your data to this entity. So that's like the initial idea behind the blind signatures, and these cryptographic protocols are not something new. Actually, they are I would say they pretty well studied. They were first developed like 40 or even 50 years ago. So there are like different schemes and different concepts. But the initial idea is that you just do not want to share your secrets. You just don't want to show the data that should be signed by some other entity. But you would like to you would like to have the ability for this data to be verifiable by third parties. But again, you don't want to show the initial contents of your messages, of your data or whatever. So this is what is the blindness property tells us. So let's move a little bit further. We have the kind of adjustment to this blindness property. We have like partial blindness, and partial blindness actually stands for that we have some public component of our signature, or even better, some publicly known data that we probably don't care about should it be hidden or not. So basically, partially blind signature tells us that we have some data, and for example, we could divide this data in two parts. One part is kind of public, so we would like to keep it public. We do not care about whether should it be hidden or not. And the second part is actually is the hidden part, something that we definitely would not like to show to someone else. So the concept here, again, keeps the same. So we would like some data to be verifiable. So the signature that we will finally gain could be verifiable by third parties. But we have this data like kind of split into these two parts, right? Like publicly known and something hidden. So this is what partially blindness tells us about. And the last one, the last property that here we need to cover is the partial blindness. Restrictiveness property. So restrictiveness is, as the name suggests, is something that we could restrict. And for that being said, I mean that. For instance, in a standard digital schemes, so it doesn't matter whether we are talking about blind signatures or some other kind of digital signatures. In general, when we are talking about digital signatures, the recipient who would like to get the signature, he is not limited on the data that he will finally get the signature on, right? But the restrictiveness tells us about that the set of the messages is kind of limited. So basically, that means that when we are talking about the RPBS and this restrictiveness property in terms of in the presence of the partial blindness, that basically means that we have. Basically, we have two entities, and probably I should have started with that. So we have the recipient and the signer, right? So recipient is someone who would like some data to be signed, and signer is basically someone who signs this data. But we would like this data to be blindly signed, so that the recipient is the only entity who knows his data, and the signer has no idea what he is basically signing. So the restrictiveness here tells us about that despite the fact that the signer doesn't know like what the data that the recipient would like to be signed, despite this fact, but he knows like something about this data, because we have this restrictiveness property. So the set of the messages that could be the signatures for which data will be finally produced is limited. So so basically that means that signer kind of knows some information about that. I mean, not the exact data that will be assigned, but he knows that the message that the recipient would gain the signature on it belongs to some set of messages, right? So that actually what RPBS stands for. So this is like several properties: restrictiveness, this is blindness, and like an adjustment like partial blindness. So basically, we have some paper that our protocol like based on. So this is the paper. So it's written by Maitland and Boyd. And probably maybe we could share the link in the show notes to this walkthrough. So basically, we have like a kind of 5-round interactive protocol here. I think I should share the screen here just to share this.
Yeah, that would be awesome. Thanks.
Yeah, I think it's now visible.
Do you wanna go to the RPBS chatter? That'll be much more easier for
yeah,
the
yeah.
sender.
Yeah. So I'll probably show the chatter and just maybe make some notes on the paper that we kind of based on. Just like a quick recap here. So can you see my screen, right?
Yes.
Yeah, clear for me. Yeah.
Yeah, cool. So basically, here you can see the paper that our initial protocol is derived from. So here it covers like how all the of these kind of digital signatures, especially blind signatures, involved, how we could combine different properties of the blind signatures like restrictiveness and partial blindness, and what kind of trade-offs should be met here, and etc. So it's just an interesting read here. What we're mostly interested here that we have some kind of interactive protocol. I'll just like take this to the bottom. So here we have 5 rounds into interactive protocol within the signer and the recipient, where we're basically performing some computations, and finally we are getting the signature, the signature for the blinded message. So I think it's better to demonstrate like our initial RPBS protocol that the paper is based on, and then we will discuss our adjustments in terms of like self-attestation mechanisms and how it differs from the original paper. So basically, this RPBS protocol, it has 2 entities, right? Like recipient and signer. So recipient would like some data to be signed, right? But he doesn't want to show this data to the signer. So this is like an interactive protocol. It has 5 rounds. It has like several steps, like preparation steps, where recipient prepares the data that that should be used in order to compute the signature. There is also some kind of commitment step, challenge step. So it's a bit similar to some other cryptographic primitives like commit reveals scheme or some other scheme. So it has some common steps here. So basically, we could just quickly move through the steps. So as I said earlier, so this is a partially blinded scheme, right? Which means that we have some public info in our data that should be signed, and we have some private part that we do that we as a recipient do not want to share with anyone, including the signer. So basically, this public part is called common info. In our builder, in our PON protocol, and especially on the builder side, we are including like multiple data here into the common info, like slot number, like builder wallet address, like the bid amount, and some other data. Yeah, just please correct me, guys, here if I'm wrong. But so the initial idea here is in common info we could include some information that would be finally publicly available. Well, not finally, but from this very step. And we also have some message here. Here, by original message, we are meaning that we are making like some computation on all of the transactions in the block except the last one. So we would like all of the transactions to be hidden from anyone else except its initializer, like the builder. So in this case, we could refer to some kind a builder like a recipient, but it's not completely true, and I'll tell about this a little bit further. But the thing is that at the first step, the recipient kind of blinds the original message. So the original message is just like a set of all the transactions of the block that should be hidden from anyone else except the last transaction. The last transaction is going to the payout pool, right? So this blinding operation is just simply hashing, and nothing at all. So finally, after this step, we get some common info, which also actually a hash of this data, like slot number, like bid amount, and etc. So and then the recipient just sends these values to the signer. The signer then makes some commitment. Commitment in general tells us that like the signer commits to some data. By saying this, we mean that he picked some random values. We just multiplied or raised some values to these random values, and then we produce some kind of structure which then we name a commitment, and then and then the signer sends this commitment back to the recipient. So and now this scheme is organized as follows. So the recipient needs to produce some challenge, which is then will be solved by the signer. So here again we produce some computations. Here I wouldn't go like into much details here, just would say that we just producing a challenge here, given within the parameters that we got from the commitment phase of the signer and some other random values. So I will tell about these random values a little bit further when we will discuss the self-attestation adjustments for this scheme. So after we produce this challenge, the signer would just solve this challenge, meaning that he again computes some values and produce some other structure, which is the solution to this challenge. You could treat it as some kind of like tricky equation, let's say like this. So the signer just solves some quiz maybe or puzzle and just sends it back to the recipient. And the last phase here is the signature unblinding, where we basically the recipient could produce the signature. So basically, the final line here is the structure that represents the signature and the message itself. One thing that I would like to mention here. So basically, there are some parameters here, but the last parameter, let's say, it is like the blinded well, it's not the blinded message itself, it's some other message that is dependent on the initial blinded message. So I will try to explain this in a more proper way. So basically, if we look at maybe probably the majority of the blind signature schemes, we will see that so it works probably as follows. So we also have like the two-party protocol. We have the recipient and the signer. So recipient just blinds some message that he would like to hide, and then he sends this data to the signer. The signer checks that like the recipient like is the valid entity, and he is like allowed to perform that operations. And the signer then just produces the signature for this blinded message, and then the signer could so based on the signature for this blinded message, the recipient could somehow the recipient could some kind of compute the signature for the unblinded, for the initial message. So again, here the recipient just blinds the original message. He sends it to the signer. Signer produces some checks and produces the signature for this blinded message and sends it back to the recipient. And then the recipients could recalculate the signature for the initial unblinded message given the signature for the blinded message. So this scheme that we are based on is a little bit different in terms of that the final signature that is produced. It is produced not for the initial initial message. By initial, I mean that we have original message, right? We have like a blinded message, and so basically we have some kind of modification, let's say, of this blinded message, because here we see that we doing some additional calculations here. At the end of the day, we produce the signature not for the original MSG, not for the blinded message, but we are producing the signature for this M1 head, right? So here you see we have like these components of the signature, of the RPBS signature, and one of these components is this M1 head, but this M1 head is not the original message. and it is not the blinded message. It's not the hash of the original message. It's let's say some kind of the modification, because here we are like multiplying these to some random values and then multiplying it by another values, like a base generation point raised to another random values. So this is like a kind of our peculiarity of our scheme. So we are not producing the signature on the original message or on the blinded message. We are producing it on some kind of modification here. Just like good to know here. So finally, when this 5-round protocol is finished, then probably we are happy here. We have these 6 components, right? The last one is again this M1 hat, which is like, let's say, a modification of the blinded message. So when we sorry,
it allows us to protect, right, the message being blinded, right? This M1.
Yeah. So we could probably treat it like an additional extra safety mechanism here for protection, but it's like just interesting fact that it's not common. I wouldn't say it's not common practice, but it's just peculiarity. So actually, there are not many like blind signature schemes that like using that are computing the signature not on the initial message, but rather on some kind of modification here. Well, at least to the best of my knowledge. So after this signature is produced, we are happy here, which basically means that we could give this set of parameters to anyone who would like to verify our signature. Well, we should also for verification. So in order to make a verification, we should also supply like the public key, right? And we also need to supply the common info apart from these parts of the signature. So with all this data, we could like send these let's say parameters to anyone who we would like to verify our signature. And this someone who would like to verify our signature has no idea actually what is hidden behind this M1 hat, which is again like some kind of modification of the blinded message. And this blinded message is the hash, right? And you know that the hash, you couldn't like reverse the hash. So yeah, here
we're protecting the block contents, right? But we're giving the partial element allows the builder to say, yeah, look, I've got a payment transaction. Right?
Yeah, correct. Yeah, correct. So we protect like the original message from the revealing in kind of let's say 2 steps, right? Because here you cannot reproduce the discrete log here, right? So from M1 hat you cannot get here the M, right? Because it's a discrete log problem, and even here. So even if, at some point in the future, it would be doable, which is like highly unlikely here, we again have some kind of protection here because we have like a reversible operation, which is like a hashing. So this is a 5 rounds protocol here. It's interactive because we have 2 participants here, recipient and the signer. So that is something that we have also implemented in our code, but in our production code, we kind of decided to go further, and we decided to unite these 2 entities. So for now, our scheme is different in terms of how we treat which entities are participating in the scheme. So in our in our like updated scheme, let's say, let's call it like that. So we unite our entities like recipient and signer, and we call this entity like self-attester, which means that this single entity performs actions from both recipient and the signer, which again means that all of the 5 rounds are performed from the single entity. So it's again a 5-round protocol, but it's not interactive because you don't need this communication between like 2 entities. You don't need to send this data over the network. So you just like a single entity, and you are computing, and you're just computing all the steps by yourself. The thing is, what we want here to achieve is that we still would like to have the unforgeability property, right? So even if I'm as a self-attester would like to behave maliciously, if I've computed something wrong here and I've produced finally some signature, if I would provide that to someone for verification, so the verification will fail. So the main property that we would like to not to implement but to keep here, let's say, is the unforgeability. It's impossible. If something went wrong, it would be noticeable. That's what I mean. That also means that we a bit of adjust our scheme. So again, we have like a self-attest entity which performs actions from both recipient and signer standpoints, and that means that like every step is performed by this self-attester entity. The little adjustment that we have here. So previously, I've told about these kind of parameters that were taken randomly and at uniform fashion. Here we made some kind of adjustment. In order to keep the unforgeability property, we produce these 6 parameters in deterministic values. So let me just show it. Yes, so this is like a self-attestation mechanism where we have like this recipient and signer union, so we've adjusted our scheme in that round. That previously we've produced these values randomly, right? Randomly and uniformly, and now we concat some data common info. Remember, this is like the public component of our data that we would like to sign. We have also some blinded message, and we have also signer's private key, but it's now like a self-attester's private key. So it's originally from the signers, but since self-attester is the signer and the recipient at the same time, so that basically means that self-attester has this private key. So we just concatenating like these values with some predefined integers, and then like deterministically produce the hash of these values. So here at this step, at the round three of this protocol where we're computing the challenge, we just produce them in a deterministic way, not within the random way, but in the deterministic way. So thus we could guarantee unforgeability property and keep the scheme secure in the scenario that we use in the PON. Probably, well, actually, I don't know. Should I cover some other details of the RPBS?
So Peter, yeah, so the RPBS is natively an interactive protocol. The self-attestation scheme makes it non-interactable. So whenever the builder is giving that a self-attested proof, later on the relayer can just check it, or any other parties can check it any number of times, right? So that's what the reporter does. It goes, it get the RPBS proof and just use a designated verifier and just check it. So that this will allow um, to verify the data integrity of a negotiation happening off chain um, to be validated against an on-chain published data later on, so the block space. For example, at T0, the builder has negotiated a block through the relayer to validator, and the validator given the sign, and the sign has the signature has been passed on back to the builder publish. But for whatever the reason, it did not get through. So the reporter has to go and it's validated. How do you know what happened in the off-chain, right? So you're not there. You only have this on-chain information that could be the missed slot. It could be completely like the builder just failed to publish it. So this is somewhere that the optimistic relay, all this kind of guys just take the collateral. So in the PON, you don't really have that kind of a notion of collateral, so which basically limit how much bid that he can make. Here, it's an unbounded bid. There is a minimum stake amount. That's a different concept. But the contingent liability, the concept of the contingent liability is like you will have to pay a penalty based on the outcome of a future outcome. So a future outcome needs to be validated from a past action. The past action here is the data that has been propagated between two parties. You need to know which party has propagated. Is that data is indeed the same data that's what you're checking against, then you can actually do it. Here, this proof, the self-attestation scheme, what it does is interactive proof. The interactive zero knowledge scheme is, quote unquote, has been very much in usage for in digital security for in the cloud system that everywhere. This is widely known technique to ensure the cryptographic guarantee of you have some data and then you're making sure the bigger party is actually not tampering or not spoofing your data, and then you're actually getting what the data that you're asking for. For example, if you have a mobile phone, you have the information coming from a big guy from a cloud. That's like a very high performance computation system, right? So you just want to make sure that your data, what you're costing, is not really giving tampered. So the interactive zero knowledge scheme has been widely in usage in our everyday life, for years, and you use it. You, me, everyone use it for all kind of devices. But the problem is interactive zero knowledge scheme is not transferable. You need to make it transferable. You need to make it non-interactive, right? That's what is happening with the self-attestation. All the things that you did in isolation can be created as a zero knowledge scheme and can be given to another party, and that party can indeed verify that what you've done in the past with the future information. Does that make sense?
Yeah, absolutely correct. So once you've produced like this signature, you could provide this data, I mean, the components of the signature among ways the public key and the common info, like these publicly available parts of your data. So once you're given like all these parts, it could be verifiable by everyone at any time in the future. Yeah.
Right, and it is super lightweight. It's ad hoc. You don't really need to have any validator. You don't really need to have like a network or a CRS string screen, and nothing like that. It's just like it's a software in isolation. You can run it, but let's take a step back and see what it actually brings. If you read this kind of Pepsi, that the proposer protocol enforced proposer commitment scheme and all this kind of a proposal, you need an on-chain protocol proposer builder separation, need an intermediary to keep the data to verify, to make it available for other parties to verify it later. Quote unquote, the system that you lean for bringing an outside party for this called data availability scheme. But the data availability is not something that you needed here because that is something different reason. You don't really need to bring an exogenous party. And that's basically make the mechanism to go. The confidence in the mechanism will be extremely low because you have an exogenous party. What you have here is you can just remove all those kind of things. You don't really need any data availability thing. You can have a data integrity checks, right? That's being performed and cryptographically guaranteed. And this is the system that basically gets you things much more lean and straightforward to make an in-protocol PBS faster, leaner, better, decentralized, permissionless, you name it. Anyone can run it. The software is super, super lightweight. You can run it anywhere. Reporter can be run on a mobile phone if you need it. So you don't really need any data availability layer to do in protocol PBS. If you guys are really thinking about that one, anyone is doing research, don't waste your time. You don't really need it. And if you want to bring that one, you will be compromising hell of a stuff in the mechanism part. Sorry, that's basically just want to do it because there's a lot of talk about like how do you store this information because this is a very one of the contentious point. You have something happen off chain, you want to reconcile that data later on with an on-chain proof, but you need to store somewhere. You need to make sure this happened. You need to have some proof. All of this actually goes through the window. Just use classic, zero-knowledge scheme that has been widely used, tested for decades, reusing it for many other things. Go lightweight. This will actually speed the innovation much faster. All right. So do you want to go to the other sections? Cool.
Well, I'm not sure whether we are left here from the RPBS standpoint and self-attestation. So I think we've covered like it's in a good fashion here. Yeah.
Right. Shall we cover the relayer and the reporter?
I was gonna show more or less the common info that more or less the builder would be signing, which of course a relay and reporter can verify on chain.
Could you explain what is a common info, what is needed here from a builder perspective? Because this is related to the header relay, right? That's what you're going to give as a common info, right? Everyone to agree.
Yeah. I should be sharing my screen now. Start sharing. Let me stop and share again.
Yeah, I was able to see it, but yeah, try again.
Okay.
Yeah, I see builder 2. I can see terminal builder 2.
Okay. Okay. So if you can't see my screen, the common info signed by a builder. 1 second. So on the screen currently is the builder logs, for which the builder is preparing bids to send to a relay. All successful logs unless there are errors thrown during the bid process. But scrolling through, the builder would get attributes ahead of the slot. So more or less you have a lot of ample time actually to start building blocks which are valid and verifiable through Get's engine. And then having built these blocks starting from about 6-8 seconds, depending on when the attributes are available, there is a transaction creation and wallet check for the payout pool. Of this transaction created, the transaction is committed and then hashed into the block as the last transaction. And then the block has other transactions which should give the block some value to the builder. If it's the first block, there isn't an existing value. If there is a previous value to beat. Now, in terms of the signature generation, the signature is generated out of information that will be commonly available on chain to everyone, reporters, relayers, other viewers or parties that would view the block and compare against the signature provided. So with this on-chain information known about the builder wallets through the wallets registry, the slots to which it was proposed for, and the amounts that the builder more or less attested to, there is a transaction, which is the raw transaction, which you can get from the chain, or if it was omitted on the chain, to verify against the signature the builder provided. So this is what we term as common info, to which is included and signed over by the builder. Attached to this signature generated out of the common info and the blinded parts of the header is the builder's public key for the RPBS service or RPBS self-attester scheme they're running. So in submission, this is included. In submission, this is included as the public key to the bid and the signature included, to which the builder then signs over both by BLS and by ECDSA. They said there is a need for an ECDSA signature because we have an on-chain registry, which then you can have other protocols that can layer off of these bid values and then have signatures over block bits, which you can verify on-chain as well, as this entire bit can be hashed and either verified by a contract or other other implementations by a different reporter entity that would like to verify a block bid aside the block itself as well. So these are a few ways which these are a few ways which RPBS is used, and specifically for builders, the signature created from that common info, which you can get post block on chain at any point in time as being a viewer or a reporter or any other entity. You can verify the signature to which relays and reporters do, and I guess Vincent will walk you through that. Lastly, before I forget, builders, as mentioned, there are endpoints that builders do run to to place block bids, but I did mention about bulletin boards, which will be more touched on broadly on the relay. But there are bulletin boards to which builders and other entities can subscribe to know the transparency of the entire order flow from the point of bidding all the way to the point of block publication into the chain, and to which builders too can build more efficiently and waste less time block building and auction in the auction process, since it's an open auction process. So you can't subscribe to these bulletin boards and build bids off of them. This is not within the software because everybody has their own bidding strategy, their own methods to which they want to bid and beat the auction system. So we do provide sample scripts to which you can subscribe to certain topics like highest bid and make and take actions on those messages within the bulletin board for the open auction, either to increase your bid value, attempt to outbid, or to send a bounty bid at that point in time, depending on like the amount of time left. Because if, let's say, you had 6 seconds, you can still wait out and perform normal bidding or attempt to bounty bid at the speculated time. However, you can subscribe to other topics like the payload attributes being requested or the slot header being requested. Everything is made transparent, not only to the bid scripts you write, but to reporters and other entities that want to subscribe to this bulletin board to take actions based off of the different entities' activities on the board. So if I just show you, for instance, there are current builders that are running this infrastructure, and for instance, for a given slot, there are actions that are taken. For instance, if it's a bid by setting addresses, you can whitelist them and attempt to not outbid those addresses. But however, if it's an address by a different entity, you can choose to outbid that specified address by providing like a higher bid value based off of these bulletin board messages. This is a lot faster because you get these messages almost like 100 times, correct me if I'm wrong, about 90 to 100 times much more faster than a JSON response you receive from the builder software. So you can make timely actions and timely bid values or timely reporting by listening to the bulletin board and submitting bids successfully to your relays and to proposals in that sense. So bulletin boards would more broadly be covered when we discuss about the relays and how reporters too would be interacting with the entire network.
Cool. Vincent, do you want to take it off from the, yeah, or we're going to relay or something?
Yeah, I don't mind which way we do it. I think the reporter is relying on relay to sort of bring it all together. So I guess it's one of the final pieces. So
Yeah. Before stepping
Yeah,
in,
go on.
just to be very clear that the reporter and the OFA could be completely two different layers and could also be coupled together too, right? You can have multiple relayers serving one auction order flow. Could be no problem with that. So it's very modular. But for the V0, we just making sure that it's just one relayer is hosting order auction flow, but you could have order auction flow. Order flow auctions are independent from the relayer software, and the relayers are just taking care of that, just propagating for order auction flow. So anyone can implement their own order flow auctions. Again, this might need MEV plus. So every other MEV players who want to contribute to the system, contribute to the ecosystem in a better way to helping the protocol searchers build this, you guys have to wait a little bit longer for the MEV plus for a few weeks. But just to say that the software system is constructed in such a way you can have completely modular. You can decouple the relayer and order flow auction.
So it's, the innovation possible in the MEV lifechain is really exciting. We can't even imagine what's going to be done with the platform, but the flexibility is there for sure. That's the point, right?
All right. So the relayer.
Okay then. Okay guys, let's get the ball rolling. So yeah, hey everyone. Now it's time for relay, one of the final pieces of the whole puzzle. Just one question, guys. I mean, this will get edited, right? So I can show private keys and all.
Yeah, sure.
Yeah. Okay. Yeah. So yeah, we getting started with relay, the final piece. Let me share my screen.
In any case, you don't want to show the private keys, even if it is getting edited. But
yeah, true. I will try to avoid it as much as possible. Okay. This is asking for my screen. Cool. Yeah. So firstly, if you are planning on running a relay, we kind of we encourage people to run their own relays. We want to create this whole network of a whole ecosystem with multiple relays where builders have endless opportunities, proposers have endless suppliers, so that this demand and supply curve can be perfectly matched. So when we started out with PON, as it was pretty evident from the introductory remark, we saw that the whole thing is kind of really skewed in the sense that there are central parties who has access to all the data, who has all the centralized power, who can do things that can completely disrupt this order flow, completely disrupt the whole flow of MEV. So we thought of changing that, and in center of all that lies the relayer. A quick relayer was introduced post merge because people started realizing that okay, now since the merge has happened, there are hundreds of thousands of validators who we can't trust, and every 12 seconds we will be having a new validator coming in, and you can't trust them with like the searchers and the builders directly can't trust them by giving them all their transactions. They can definitely backrun them. So that's where relay came in. The relay kind of acts as a, like we all know, like abstraction from like our like all the basic whoops we kept hearing abstraction. So relay is just the abstraction layer here, which kind of protects the builders from the proposers themselves. But the issue here is that as it was designed and as it eventually turned out, the relays kind of had a lot of powers, and we just wanted to make that we wanted to abstract away more things from relay so that everything can be done on builder level itself. So just to give an idea, like basically the relayers kind of work based on the builders give them their blocks as they are rightly named builders. The relay kind of creates an abstracted header out of it, which is then provided to the proposers. The proposers sign over the header, and because of the beauty of SSZ, like the Ethereum, I mean, like Beacon uses SSZ. The signature over this header turn eventually is the signature over the complete block, which then the relayer or maybe the proposer itself can submit to the chain. So that's how the whole process works. But what we here do is like, instead of sending in the complete block, as we mentioned, the proposer only will send like the builder will only send like a abstracted header of the whole block, which relay will kind of, as it is rightly named relay, it shouldn't do anything more than that. It shouldn't be like poking its nose around. It just needs to relay the whatever comes from builder and send it to proposer. Proposer signs over it. Relay then again relays the message to builder, and the whole flow is completed. So this is something that we have already covered. But now to understand like how exactly you want to run a relay from the infrastructure point of view, in our documentation it is very well like written. I mean, you can definitely follow the like our documentation. If you go to relay setup, of course this is like a it's a Golang implementation. So you can either if you have Golang on your machine, you can you are free to build it from source and run. You can use the binaries that we provide, and in the and in very near future, we will also come up with a Dockerized version that you can run on your like a Docker VM itself. No need to do anything else. But yeah, like there are some prerequisites to run a relay, because relay at the end of the day needs data from a lot of sources to validate everything, to make sure that none of the parties involved, because all the parties in the system kind of revolved around the relay. We need to make sure that no one is kind of no one loses anything at any point of time. So firstly, you need a beacon client. Like you need to, it's fine if you don't have like the archival database and all set up. You just need the like header, like last maybe couple of slots of data. So just connect with your connect with your beacon client. Yeah, if you want to make sure to, if you want to use the default values on our relay, just create a tunnel from your port 3500 to whatever port like the beacon API is exposed on your client. You will need access to the subgraph, like subgraph as in our PON pool. So all our contracts on the like PON pool, like payout pool and everything, they are being kind of indexed by the subgraphs, which work as a single source of data. So you definitely need access to it. MQTT database, of course, all this we will come back to it. But yeah, once you have everything set up, you can follow this kind of instructions to set up all the peripheral infrastructures like database, Redis server, and all those kind of things. We also have Docker Compose files here for you. Maybe if you're interested, you can just follow the Docker Compose. We have a complete package for with Docker, multiple Docker Compose files that you can use to set up a combination of infrastructure, and you can just set it up in a single command. But coming back to like running the main relay, you will see that you just, here we are showing an example of how to build it from source. You can just use the run command. We have Cobra interfaces that can run it for you. And we have multiple possibilities of adding multiple flags. So we have tried to make it as composable as possible, as versatile as possible. So you have the possibility of doing multiple things. So just to give you a very short idea of what are the parameters that you can provide. So firstly, on the relay point of view, you definitely need to provide a URL. Basically, URL is the port on which you want to run your relay server. That is the main server binding it, main package binding everything together. You need to provide the beacon URL. So our beacon interface kind of supports multiple provision of connecting with multiple beacon clients, so that let's say one of service like service quality of service of any one beacon client degrades over time, we can easily switch over to the best possible beacon URL. So you just need to provide all your beacon URLs in a comma separated manner. You definitely need to provide your secret key so that the relay can sign over the messages and the proposer can be sure of that. You need to provide the network. So network, as in currently our relay supports Goerli, Sepolia, and Mainnet. But if you wanna run your own custom testnet as well, that's also possible. So we kind of fetch as much data as possible from your beacon client itself. For some of the very basic fields, like what's the chain ID of the custom net and all, if you are specifying your network as custom devnet, you also need to add a flag saying custom chain ID, where you need to provide the chain ID, and you are free to run it with any chain possible. So theoretically, any chain can be your custom testnet, and you can run it even like, let's say, already live mainnet, EVM mainnet. Yeah. Then you definitely need to provide bit timeout. This is a parameter that you can tune based on what's your infrastructure. This is like the time for which you want to retain a bit for the relays, and you want to kind of make them invalid after that. Then you, of course, have all the parameters to tune your HTTP client that are continuously interacting with your relay server. You have the read timeout, idle timeout, everything. If you want, you can definitely provide it, but we have also kept default values based on all the testing that we have done. Whatever we have observed, we have kept the best possible values here. So you are free to skip all this as well, but definitely don't skip your secret key. From infrastructure side, you need to provide your DB URI. To be very precise, you need to provide the URI, not the URL. So it needs to be in form of like it needs to contain your client admin, your client username, password, and all the connecting host and port and everything. And you need to provide that. You also need to provide your Redis URI, which if you are using our Docker Compose file, you will see that it's just running on the localhost port. You then again need to provide, you can, if you want, you can provide the DB connections, idle connections, those kind of things. But again, we have the default values there. You also need to provide a DB driver. Let's say if you are using a DB other than Postgres. Firstly, we only support SQL DBs for now. And in case you decide to go with something other than Postgres, you need to specify the DB driver flag as well with the appropriate Golang driver name of that particular DB. It can be MySQL, it can be DolphinSQL, it can be TimesQL, anything. You also need to provide your PON pool URL, which is the subgraph API URL here. And if needed, if you have authentications around that, you need to provide the API key as well. And finally comes the bulletin board. We will definitely dive deep into what is bulletin board, but just to give you an idea, you can consider this to be a MQTT broker service. So you need to provide a bulletin board broker like client, which of course you should have set up your own or you can use a hosted service for that. You should provide the port of your bulletin board broker. You should provide the client, then the username and the password. Just to be very sure that your client and username should have permissions to publish messages for the particular topics that relay uses. And the list can be found on the README itself. So be very sure that you have permissions for posting messages there. But yeah, that's how you can run the relay. You can also go to our repository, the bulletin board relay. You can fork it, you can build it from source, you can use the binaries and all. You can do go install, that's it. And once you are done with running your own relay, to make it more visible, you can just create a PR to our repo, and we will add that as a whitelisted relay. You will have a look. You can have a look at the README for instructions around that. Yeah. Just to give you an idea of like what we have been doing with our relay for the last couple of months, like all the testing that we have done, these are the statistics from our devnet testing. You can see like all the builder bits
sorry,
that are
We both are interfering. Sorry. Go ahead, Vincent.
I was just gonna say, like the whitelisting thing. I just think it might be useful to touch on, what the whitelisting thing. Like it sounds, it sounds permissioned, right? But it's like
the
just
whitelisting
explain.
what is it for? Yeah, so the whitelisting is not required for running a relay. Whitelisting is only required for the relayers to get a tax cut of the collected MEV payout. So this is for relayers payouts. The relayers can collect some money from aggregated revenue that has been, from some monthly or weekly fees, whatever the peon DAO decide. They can get a share of the a percentage that has been collected from the MEV coordinated between the actors. So it's for sustainable relay ecosystem fund that is collected through this kind of whatever the bids has been processed. But you don't really need to whitelist to run a relay.
Right. Yeah. Of course. I mean, you definitely don't need to whitelist to be part of a whitelist to run your relay. It's just to be part of the ecosystem and like get payouts, maybe to increase visibility of it. Yeah.
If you're a relay, if you want to have fund, just whitelist yourself. Just pull a PR. So your address, your address could be added, and you can collect some money, for the services that you're rendering for the ecosystem.
Yeah, exactly. Yeah.
It's very funny because everyone just jumped in. No whitelist, no permission.
Yeah, I realized that like the moment I finished the sentence.
All right, cool.
Yeah. So yeah, like to have a look at what we have been doing with our DevNet, you can see like we have all these validators registered. We have like builders coming in, reporters coming in. You can see like the total sum of bits that we have been doing over the time with our testnet. It has been a very like the current testnet has been up for just a couple of days now, and like but the bits may be small, but we are kind of running it into its full potential and seeing a like significant scalability from like builders and proposer perspective. So that's, you can just log into our watcher service, not log in, you can just tune into our watcher service, and it's something that we have built using the support of Metabase, and you can just look at the stats and all. And in fact, we do support Metabase dashboards for your relay out of the box. You can again go into the Docker Compose and see instructions on how to set up your Metabase service. You will have your own like dashboard for your own relay, and you can like expose the URL for the world to just go and see the stats around your relay. And most importantly, since it's Metabase, you can always go and play around and build your own queries. It's like a Dune dashboard and do a lot of stuff. So the relays that you will be running, they will be a gold mine for data. They are a gold mine for MEV data. If you need anything, just build a query around that. So that's from Metabase point of view, like the dashboard point of view. Now maybe let's just have a quick look around the things that we kind of have on the code front. Guys, do you want me to like do a dive into code, or should we skip it?
You can go over, like skim over what the relay does, because relay basically do very minimal things here.
Yeah, right. Okay. Yeah, so our relay is kind of like, it's a very modular thing. There is separate modules for everything. The at the core of it is, of course, the relay itself, like the relay server, which kind of relays messages from one end to another. There are multiple endpoints designated for multiple parties. Firstly, you just saw a bounty bit. That's a very sweet alpha that's coming soon. Stay tuned for that. But apart from that, you have the ability to submit block. Definitely, the builders need to come in and submit block. Once the block comes in, we kind of do some sanity checks. Of course, we definitely said that the relays should just relay and they shouldn't poke their nose around. But the thing is, we want to also make sure that for the whole Ethereum network, the possibility of missing a slot should be minimum, so that the finality of the network is always maintained to utmost quality. So we do some basic sanity checks that can fail here and there. We also make sure that the builders and all are active based on like their deposit and everything. We kind of make sure like the uh, payload is kind of like whatever they are submitting is very like recent. They are not submitting anything that is kind of old that can become invalid for the proposer, because we don't want to provide proposer with garbage here. We also do like a RPBS verification over the like common info that was just built by the builder, and we make sure that the RPBS verification passes before we submit the block, accept the block. We also check the signature over the block to make sure everything is coming from the trusted builder itself. And finally, once everything goes according to the plan, we accept the bid and prepare from and start creating an abstract over the bid itself. We start creating different abstracted entities that can be provided to proposer, reporter, as per their request, and keep them ready. So the thing is, it's not like when proposer comes in or reporter comes in, we build stuff, we build things, build things earlier, we keep them ready, and whenever the request comes, we just provide it to them. On similar lines, we have like a proposer header request where the proposer can just come in and request for headers. This is like just a GET call that anyone can do. Maybe you or me can do it from a Postman client, and we can any API client, and we can just make a request to see what are the best possible headers. So like when the block submission finishes, we do have like either when the block submission finishes in the open bidding, or when the proposer's header request goes in, we kind of stop the open bidding. So at the end of the open bidding, we will have an auction, and we will know like the winner, basically who had the best possible bid. So we just provide them with the bid board's winning bid. So we have a package called bid board here that kind of handles all this. Like it's kind of, you can call it like a casino bidding board, that the large screens on the casino where you can actively see people going up and down. So it's just like that, a board that works completely async behind the completely in the background, and keeps just updating the auction values for different slots. And simultaneously auctions are going on for multiple slots here, because bids are coming in for multiple slots. You can bid for a slot in future as well, or the present slot as well. So the bidboard just handles that, and whenever the header request comes in, we just go to the bidboard saying that, hey, you did a lot of work, stop now and give me whatever is the winning bid. So we just do that, we provide it to the relayer proposer, and you will see that at every step we do store all this kind of like things into the database as well, so that this can work out as a like analytical source for us later, or maybe if anything goes bad, this can help as a firefighter for us. Then of course we have handle proposer payload, which kind of gets the blinded beacon block from the proposer. Blinded beacon block is basically just a signed header of the block itself, which then after the relay processes it, we see that everything is fine or not. And in case everything is fine, we just kind of make a call we go to the like bid board to see what was the associated bid with this payload. We see who was the builder for that. We go to the builder, submit him the blinded beacon block, and get the complete block from here. So once the proposer kind of submits his blinded beacon block, the duty of proposer technically finishes there, because once relay has the signature, it can just provide it to the builder, and builder already has the complete block body, the payload, the complete block. So for the slot, so the builder can theoretically submit it to the chain, and it's now the builder's duty to do it. And if he fails to do that, it will be a penalty for him. But yeah, that's like the whole thing that goes. And we again also send back a copy to the proposer as well, just to make sure if the proposer wants, it can submit it to the chain. But yeah, that's pretty much it, like the whole flow of what happens in the main relay itself. But behind all this, we have a multiple packages here doing a lot of things. We of course mentioned about the bitboard, which is just a like uh, live auction board thing, and it kind of, it's a I would say very stupid live auction board. It just knows how to do auction, nothing else. It gets value, it does continues doing the auctions, and whenever it gets a request from the relay, it just stops the auction and gives the value. So yeah, it's like a just that kind of a thing. Beacon interface, of course, we support. This is the like interface that kind of keeps talking to the beacon clients. We keep listening to the SSE events. We keep listening to the new. We keep making data requests to the beacon interface. The SSE events kind of drive the whole beacon periods and timelines of the relay. So it's not like a pull-based mechanism. It's something that the beacon client pushes the relay to change. So it's a very cool thing, completely based on SSE events. We have then comes a very important part of the relay itself, which is bulletin board. Bulletin board in its purest form is just a MQTT like pub-sub system where the relays keep publishing messages. Like whenever an auction is finished and the highest bid is won by a builder, we send in message saying this is the builder, he won the auction for this slot with this much amount, so that all the builders around him can just see and say, okay, like he won it, I should outbid him. So that's how it works. We also send in a message saying that hey, the proposer has requested the header, you shouldn't send in more bids because they will be useless. We also send in message saying the payload has been received from the proposer, so that there is a very open public visibility around everything. And all this purely works on MQTT, which definitely, being a pub-sub system, is very fast, almost 90 to 100 times faster than a classical REST API. And MQTT was purely designed for like this low resource, very low resource intensive IoT devices. So it will be very like less resource intensive, at least for the builders, thousands of builders who are listening to this open channel of information, open like pub subsystem. So it is very well suited for that. Apart from that, we of course have like a Docker Compose library to help you with all the setup and everything. And most importantly, we also have like a reporter server here. This basically acts as a source of this. This is a HTTP server that runs independent of the relay server, and its job is to purely serve the use cases of reporters. So the reporters, we will definitely have a better idea of that once we go through reporter, but they need access to multiple data sources, one of them being the relay, to create their reports, so that this server kind of just is designated to serve all the reporters that are associated with the network. So yeah, that's pretty much it, how it like what are the packages of the relay from a very high level. But if you want to like have a better understanding, please feel free to go through our code. It's
I have a
MIT for a
question.
reason.
I
Yeah.
have a question.
Yeah.
So you mentioned about this, the database that is needed for the reporter, right? For the relay. Well, it's mostly related to the order flow auction. So if you decouple the order flow auction and the relay doesn't really need to come to the picture, right?
Actually, that's true. That's true. So the thing is, relay here is just storing the values from open order flow into a database, and the reporter server is just providing providing access to that database for the reporter. So instead, if the reporter directly keeps listening to the open order flow, we can completely I mean bypass, we can completely move around the relay, because exactly
So,
what
so
relay is.
the thing it is, like, there's a lot of order flow auction guys out there, and they all want to. They are like, there's a lot of auctions they want to try it out, but they can't do it today because there's no surface that you can host this. But with the order flow, that the message broker and the bulletin board, you can host your own order flow auction, right? You don't really have to use the default auction that we're providing. And if you can provide an order flow auction, an independent order flow auction, just to be very clear, agnostic to anything that we do, you can do it. And now you could have your own relay ecosystem that just like, pinging and providing this information to the validators in a geolocation base or anything like that, right? It could be anyone who have a relay infrastructure, not necessarily for the the MEV infrastructure. Anyone who is running a node, anyone who is running in a meta transaction relayer, any kind of relayer infrastructure can actually do a relayer part. If you are a sophisticated auction can be hosted in a way that, and then that data set is only needed for the reporter. It doesn't really need to go along with the reporter. I'm just confusing with my name. It doesn't really need to go along with the relayer database all the time.
True. That's true. That's true.
It reduces the system size. It will become very lean.
Yeah, that's definitely true. It's just that we need a source of data. So if you can run your own open order flow, I mean, you can keep listening to bulletin board and build your own open order flow here, and like you can just maintain it from there. So everything goes down for the relay itself.
Yeah, cool. Thanks.
Yeah. So yeah, maybe, yeah, that's the very high level idea of our code base. You can definitely have a look at it. It's open source. Please go and have a look around it and you will see new things. Maybe we can just do a quick quick demo of how to run it. Okay, whoever is editing it, please remove please delete the,
Cool.
yeah, please just delete this secret key part here. Okay, whoever is running it, and also the DB part, just blur it. Yeah. So coming back to like our how to run the relay. So let's say you are in building it from the source. You are already, or you're already into the repo. You have cloned the repo. You are like in the root directory. You can simply do go run relay. You need to provide your secret key. You need to provide your DB URI. You need to mention the network, as we have mentioned here, custom testnet. Because we are running it with our devnet, you need to provide a board broker, the bulletin board port where the broker is running, and all the things that we mentioned. And once we just start running it, it will sync for a bit. It will start fetching the data from everywhere, start getting all the updates and everything, and it should run. Okay, did I mess up something? Oh, okay. It's the EC2 instance where you it gets overloaded and disconnects from the bigger interface because we are running a lot of stuff here. But Yep. Okay, we can start from here. So yeah, like you just need to mention like all the command line arguments, kind of some of the basic ones that are necessary for the relay to run. Relay will just start fetching the data, and yeah, it will just run. You can see all the services just kicking in one by one, and yeah, we are good to go. And as you can see, we have already started receiving bits from our builders. Maybe here it's bidding for slot 37620. It is bidding for a value of like almost 4.1 ETH. And you can always also see messages being put into the bulletin board here. You can always track that by listening to the bulletin board. And we should be getting header requests in a, yeah, as you can see, some proposer like that is registered with the PON pool requested a header as well, and yeah, also eventually submitted the proposed payload as well. And yeah, that's pretty much it, how the relay works. It's, you can just leave it like that. It will keep working, keep logging everything, keep storing the data maybe. And for visibility, it will keep putting things on the bulletin board, and you can just start creating reports post epoch around that. So yeah, I think this will be a very good segue for. And yeah, as you can see, if the messages like the bits come in late, you can also see that message saying that you have come late, or like the proposer has already requested the bid for it, the auction has been closed. So yeah, like that's pretty much it. I think we can use this as a segue for the like to present reporter that kind of is the police service for our PON.
FBI, right? Okay, cool. Thank you. Yes, this is definitely a good segue for that. So let me share my screen. Okay. So right. So the reporter can be accessed in our PON PBS GitHub. So you just have to go to the PON-reporter repository. We go into in sort of more technical terms, sort of what the reporter is. But essentially, the reporter is, I really like this slide produced here by Shubhashis. The reporters, the bounty hunters, they're basically looking for faults in the network and bringing the network back onto course and holding people accountable, right? So, and we heavily use the RPBS scheme in order to enforce credible commitments. The reporters will actually go to the payout pool for their payments. And they do it on a per epoch basis. So we have a concept of a cycle, which is about 7 days, in which proposers will perform their duties, and proposers builders will sort of do their daily operations. And they will be reportable within that cycle and just after. But so reporters, they will do is they will scan for penalties on a per epoch basis. So that, for a given epoch, they will go through 32 slots, and they will go through a sequence of steps to establish whether there was any violation. So firstly, what we need to do when we start on a given epoch that's in the path that has reached finality, and that's quite key. We don't want to deal with anything where the chain might reorg, but we basically firstly establish for a given PON relay that's in the network, did any builder actually create demand for a block? That just means that a builder submit a bid for a slot with a proposed execution layer block. So if they didn't, then we don't have to go. If there are no bids, for an epoch by any builder, we don't have to proceed any further. But if there was demand, then we need to take a look at whether things went to plan. So you want to know, okay, so for a given epoch, there will be 32 proposers. Of 32 proposers, there will be up to 32 PON proposers. And then in that, we want to make sure that everybody did their part. So that means a proposer. So if a builder submitted a bid and a proposer requested a header, they will need to sign the header if they're interacting with a P1 relayer. They can work with the other relayer, that's fine. But if you request a header from a relayer and you don't sign it, that is a penalty. If you're registered to the payout pool, you can opt out of the payout pool, and we'll go into more details into that in a bit. So if you are registered with the payout pool, then when you request a header, you need to make sure that you sign it. And you can observe with the bulletin board. You can observe whether or not you want to do that in the first place. That's the beauty of the order flow being open and for everybody. So you need to sign it and return it back. Now, if that's returned back to the relayer and the builder doesn't publish, remember the builder is in the possession of the block contents, all the transactions in the block and the entire block contents. So they are the one that are ultimately responsible for proposing the block. Once the header is signed, the builder is free to release the contents of the block, because obviously proposer cannot sign twice for a given consensus layer slot. That's up to them. So, but here, ultimately, because they have the block, they have the first opportunity to propose the block to the chain. And so it is on responsibility of them to do that. The other thing that we need to check for is whether a builder said that they had and created a credible commitment and said, yeah, I've got enough money, I'm going to pay you 2 ETH, and then they don't pay you. So we enforce a penalty on the builder of twice what they promised to pay. And if they do that, then if they fail to pay the payout pool the correct amount, then they will get penalized accordingly. We can see that, we'll be able to see that in the code. Now we basically go into those details here. What's a validator fault, builder fault? Validator fault and kicking, so that is violation of consensus layer. So if your effective balance drops below 32, if you get kicked from the consensus layer, your slash flag gets set to true, then you will be also you'll get kicked from the PON network as well. So that just extends to that one as well. We map these penalties here into internal penalty types, and there's penalty types that can be reported to the smart contract. That's where builder collateral gets slashed and proposer payments get redistributed in the case that the proposer is registered with the payout pool. We've got instructions here on how to get started, how to install the dependencies here, how to configure your scanning API. So you have a scanning API for per epoch scanning violations in the network. There is for the PON platform, there is a designated verifier where you can get the penalties that you've identified. You can get them verified by the verification API. And it goes through sort of the example requests and responses that you should receive there. What we try to do is we try to give this and make this available in an easy to use fashion in the PON SDK. So you can install the PON SDK, and you can, with not many lines of code, you can see here, you can scan for violations, construct a list of all the penalties, have them verified, and then report those violations to the smart contract. But the only thing is you need to be registered either via DApp or via SDK as a reporter in order to do this. So that's fine. So if I show you, we have so let's suppose that you have your reporting scanning API up and running, and for a POC 47 you want to scan for violations. We can trigger this and it will look for, so this is on the local development test network. These are the violations that were discovered. So in this internal penalty type was a builder underpayment. The builder actually said that they were going to pay this amount of way, and they actually made a smaller payment of that amount. We have the BLS key of the build. No, sorry. This is the BLS public key of the proposer that was selected for that slot. The builder that actually made a bid for that slot, the slot number, the execution layer block number, contract penalty type is this one. This is the penalty, which is twice the amount that they were supposed to pay. This is their commitment to actually make the payment that was verified by the relayer. And then can be verified as well by the designated verifier that it did indeed come from the builder. And all that information is enough to create a penalty for the builder. We also have an example of a proposer requesting a header, not signing, for example. What proposer was selected again? The structure is the same. And the verification is therefore straightforward because the penalties being verified are the same. So if I show you here, so we have an example script where we basically, for that epoch, we scan for violations, we'll print out the violations, we'll construct a list of penalties. So the scanning API actually returns to you the breakdown of the penalties found, each category, but you can just produce a unified list of responses because all the objects are the same, and then you can get those verified and submit that to the contract. So what we will do here is we will simply run the script. We've detected the violations that we saw on the postman, invalid payment, no signed header returned. So let me just check something. We need to have verification online, getting execution layer block number. Let's try and see why that would. Okay, so this time it succeeded. That's something for us to investigate. But this time this time it succeeded, and you have a list of all the reports that were supplied, and the list of the verification signatures that can then be submitted to the smart contract. So we've packaged it really in a simplified manner, and reporters are rewarded in ETH because builders are paying proposers ETH for their block space. So reporters are rewarded in ETH for detecting the violation. So they will get, for example, there is a structure and a specification of what they will get for a builder. They will get, half of the minimum stake amount for a builder. Proposers are compensated as well. In the case that a builder agrees with proposers, if they're registered in the payout pool, then basically they will get compensated from the builder's stake, some portion of funds that they should have received. If a proposer grieves, then a penalty is applied on their earnings, and it gets redistributed to the other proposers. We have game theory applied to this and verified by our friends at 20 Squares, who looked at the mechanics of the system and how reporters can bring this into equilibrium. So I would have a look. Just touching on if I go into the SDK, just touching on so we have the ability for proposers to register that are part of the payout pool and basically outside of the payout pool. So you basically, when you're registering outside of the payout pool, you're saying to yourself, okay, look, I want to be part of the PON network and all of the benefits, but I want to keep all of my earnings. So I want to work with builders. etc. And that's when you can basically say, you supply an alternative fee recipient. And if you supply a fee recipient, then basically you will the builders know which fee recipient from the contract to send when they are having their when builders are building the block. So it's what Ronnie was saying earlier about the when building a block, you can set the coin base, and you can set the address where payment needs to be made for the given slot. So those two things can be configured for proposers that are registered with the payout pool and outside of the payout pool. So that's pretty much the reporter in a nutshell.
Okay. All right. So we have covered all 4 layers, right? The OFA, the builder, complete relayer and reporter, and the on-chain part, the registries. Everything is very independent and it's modular and can become work in combination, work in isolation. We'll see how people are going to reuse it. So MIT license, just go ahead and use it, build on top of it, or just use our default strategy. Love to see the feedback.